Hi, Assalamualaikum warahmatullahi wabarakatuh. Alright, in this video we will learn about the trigonometric ratios. Before this, when you were in the lower form, I think during your form 3, I think you have learned about this right angled triangle in which you have the sohcha and toa. Alright, sohcha and toa means, like, for example, suppose we have the angle x is here. Right, so this is the opposite, this is the adjacent, and then this is the hypotenuse. And we know that from the Pythagorean theorem, it should be a square plus o square should be equal to h square, right? And from this, we have soh means that sine of x is equal to the opposite over the hypotenuse. And then we have the second one, which is cha, so which is adjacent over hypotenuse. So cos of x is actually adjacent over the hypotenuse. And toa means that the tangent of x should be opposite over the adjacent. So tangent of x is actually equal to o over a. And we have to remember the Pythagorean triples. Right, there are a lot of Pythagorean triples, but the one that you should know, the basic one, you have 3, 4, and 5. So what does it mean by these 3 or 4 and 5? Suppose you have this right angle triangle. If you have 3, here is 4, should be 5. The longest one should be at the hypotenuse. So this should be the hypotenuse. So what is a hypotenuse? Hypotenuse is the side that is opposite to the right angle. Alright, so the second Pythagorean triple you should remember is actually 5, 12, and 13. So the 13 should be the hypotenuse. And then you have 8, 15, and 17. And then you also have 7, 24, and 25. You can go on with a lot of other Pythagorean triples, but these are the 4 basic ones. All right, so next one. We have to know this quadrant. All right, so we call this as the first quadrant. This one is the second quadrant. This one with the third quadrant, and the last one is the fourth quadrant here. And we should know that A here stands for everything. All should be positive. Means that if you have sine, cos, and tangent, it should be positive on this side, on the first quadrant. But on the second quadrant, you have S, which is only sine is positive. So if you have cos and tangent, it should be negative. And on this quadrant, tangent should be a positive, and you should have sine and cos should be negative. And the last one, the fourth quadrant, only cos is positive, means that if you have sine and tangent, they should be negative. And how you remember this? So I usually use aku stay C. Alright, so up to you. I usually use aku stay C. Aku stay C. Done. Alright. Now, suppose we have this. Like, for example, we have tangent theta, which is equal to 3 over 4. So what does it mean by this equation? So it means that the tangent is, in this case, tangent is positive. So it is positive here. So tangent should be positive. Means on the first quadrant, because all is positive here. And tangent should be positive. So it means that the theta should be here. Alright, so that theta should be there. Okay, something like that. Right, so if you want to sketch your, what we call this, so this is, I usually write acostasis, so tangent, all positive, so theta can be here, and theta can also be here, right? So you have toa, opposite, tangent is actually opposite over adjacent, right? So tangent theta is 3 over 4, or it should be 3 over 4. So we know that by Pythagorean triple, this one should be 5 because that's the hypotenuse. All right, if you have, what do we call? Another statement which says that sine theta, which is equal to negative 3 over 5. So you should first sketch your acostasis here. Right, so you have acostasis. And then you should know where is sine positive. So this one, everything is positive, and this one is sine positive, means that your theta should be either here or it's here. All right, it should be here. All right, so because what do we call this, on this third and fourth quadrant, sine is negative. So 3 over 5, so soh opposite over hypotenuse, means that you have opposite of theta is 3 and hypotenuse is 5. What about this negative? You just ignore it. The negative just represent which quadrant it belongs to. All right, so same goes to this 3, so 3/5, something like that. Right, so either in the third quadrant or the fourth quadrant. Another important thing is that you have to know that if you have like a, all right, if you have like for example, all right, if you have this angle, so it is from 0 to 90 degrees. So below 90 degrees, we call this as angle as acute angle because it's very cute, it's small, it's acute angle. And then we have a smaller one, a bigger one, so we call it as the obtuse angle. So obtuse angle should be on this side, so, right, because obtuse, so all right, so acute is from 0 to 90 degrees or below 90 degrees, and then you have the obtuse, which is from obtuse is actually 90 degrees to 180 degrees, right? So it's greater than 90 but it's less than 180. And then if you have like a reflex angle, all right, it can be here or here. So reflex angle should be greater than 180 degrees but less than 260 degrees. So that one you should remember sometimes, because sometimes the words use acute, obtuse, and reflex angle. All right, that's the idea. Next one, we have to know the trigonometric identities. All right, so we have to write these trigonometric identities. If you have sine of -a, because sine is actually an odd function, so that one will be a negative sine of a. And then if you have cos of -a, that one is an even function, so this will remain as cos of a. And you should know that tangent is actually an odd function, therefore it should be a negative tangent of a. All right, and tangent of a, if you can write this, it should be TSC. All right, so I should always remember it as TSC, sine of a over cos a. All right, so t equal to sine over cos, TSC. All right, now I have secant, so you look at the third word here, so it should be 1 over cos of a. And cosecant, you should look at the third word here, third letter here, right? So cosecant of a, so that one should be 1 over sine of a, because it is s here. That one is secant because 1 over cos, right? So C that. And this one cotangent, so you look at the third word, so it should be 1 over tangent of a. Or if you invert this one, 1 over tangent of a should be cos of a divided by sine of a, right? So these are some identities that you have to know how to use it, because I think this one are given in exam, right? But at least you know how to use it. All right, so if you have sine squared a plus cos squared a, it should be equal to 1. And then if you have 1 plus tangent square of a, so this is actually equal to secant square of a. And if you have 1 plus cotangent square of a, this one should be equal to cosecant square of a. All right, now the addition between two angles. All right, so you have sine a plus minus b, means you will have sine a cos b, all right, plus with cos a sine b. If it is plus, then it should be plus. If it is negative, it should be negative. All right, so the symbol does not change. But if you have cos of a plus minus b, then you will have cos a cos b, right? Because it starts with cos, so it's with cos first. All right, cos a cos b. If it is plus, then it will become minus. If it is negative, so it should be positive. So the symbol is now inverted. All right, so negative minus plus sine a sine b. All right, so that's for the addition of the angles for cos. And now you have that one for the tangent. So for the tangent, you will get the fraction. So tangent, if it is plus minus, so this one should be plus minus tangent of b, all right, divided by 1 minus plus tangent a tangent b. All right, so you should know these are different symbols. All right, I hope you get the idea, right? Now, for the double angle, if you have sine of 2a, this should be 2 sine a cos a, all right, as simple as this. And if you have cos of 2a, you can write this in 3 equations. So cos square a minus sine square a, or 2 cos square a minus 1, or 1 minus 2 sine squared of a. All right, so you can write any of these, all right, depending on your equation. And then you have a tangent of 2a, which is given by 2 tangent of a over 1 minus tangent squared of a. Hello, Sankom. Okay, let's now look at these special angles. Many of students do not like these special angles, but it's actually easy. All right, follow me. You have to draw 2 triangles. All right, so you assume this as 1 and this one as 1. So of course this is 1 and 1. If you have this hypotenuse, so this one should be an isosceles triangle, so the angle here should be 45 degrees, right? 45 degrees. All right, so by what do we call Pythagoras theorem, right? So you get square root 2 here, because square root of 1 plus with 1. All right, so now you have to, all right, so if you have an angle 45 degrees, so in radian it should be pi over 4. All right, if pi is actually 180, so if pi divided by 4 should be 45 degrees. Right, now suppose that this is x, right? So you assume that this one is x, right? This one is x, all right? So this is x now. Right, so to find the sine and cos of and tangent of x is not difficult for this one. So you will easily obtain, all right, so you know that soh, cha, and tawa, right? So soh means sine of 45 for this one is actually opposite of hypotenuse, so this is these two, all right? So 1 over square root of 2, all right? And then for the cos of a, of cos of x, so of course cha, so cha means adjacent over hypotenuse, so also you get 1 over square root of 2, all right? And the last one, which is tangent, which is given by opposite of a hypotenuse, so opposite of adjacent, so opposite is this one, and adjacent for 45, which is 1, so 1 over 1 should be 1. So you get the angles for the 45 degrees. Now if you have, like for example, for the 30 and 60 degrees, so what should you do? All right, so you should draw, like follow me. Just now you have drawn 1 and 1, and you get the hypotenuse, which is square root 2. But for 30 and 60 degrees, you have to sketch, right? Follow me. You have to start sketching 1 and 2, something like this. All right, I repeat. You start with 1, and you have 2 here. All right, 2 as the hypotenuse. All right, so now you connect this one, and you get the what do we call the length for this one, which is given by square root of 2 squared minus 1, which is 4 minus 1 will be 3. So square root of 3 is that. So remember, you start with 1 and 2 for the hypotenuse for this one. So the bigger one is actually 60 degrees, and the smaller one should be 30 degrees. All right, you can see the difference between the angles. So of course the bigger one should be 60 and the smaller one should be 30. Remember, start with 1 and 2. So this one is the bigger one, should be 60, and this one is smaller one, should be 30 degrees. All right, so as simple as that. Again, you have to use the soh, cha, and tawa. All right, for 30 degrees, actually pi over 6, and for the 60 degrees, which is given by pi over 3. All right, if you have sine of x, means the angle 30, for example. So look at the angle 30. All right, so assume our angle is here now. So now we have actually 30, so opposite over hypotenuse. So opposite over hypotenuse, so sine of 30 should be 1 over 2. cos of 30 should be given by cha, adjacent over hypotenuse. So this is our 30. So this is adjacent over hypotenuse, square root 3 over 2. And last one should be tangent of x, which is tangent of 30. Toa, opposite over adjacent. So 1 over square root 3. So that is the sine and cos and tangent for the 30 degrees. But for the 60 degrees, all right, let's now assume that our angle is there. So our x is there now. So you know this here is 1, 2, and square root 3. For sine of 30, opposite over hypotenuse. Opposite of 30 is square root 3 over 2. So you have square root 3 over 2 is the sine. And for the cos of 60, all right, so cos of 60 should be cha, adjacent over hypotenuse. So adjacent is here over hypotenuse 1 over 2. And finally, tangent of 30 is 60, right? Opposite over adjacent, right? So square root 3 over 1. So it should be square root 3. So we are done with the sine, cos, and tangent of the special angles 30, 45 degrees, and also 60 degrees. So remember, I repeat, you start with 1, 40, 45 degrees. And then you start with 1, 2 for the, what do we call? 60 and 30 degrees. All right, so 1, 2. Remember, 1, 2. All right, so that's it for this one. All right, now, another important thing you have to know is the graph for the sine, cos, and also tangent. All right, so you have, suppose you have 1 here and negative 1 here. So of course your graph should look like this, right? All right, okay. So means that tangent, this one is sine of theta, and suppose our angle theta here. So sine of theta, so sine of 90 degrees should be 1, all right? Sine of 90 degrees should be 1. Sine of 180 should be 0. Sine of 270 should be negative 1. And sine of 360 should be 0. Alright, now if you have, like for example, for cos of theta, and our angle theta is here, you should start at 1, alright? So something like this. It should be something like this. Okay, I hope you get the idea on how to sketch this one. So cos of 0 should be 1 because the value is 1 here. Cos of 90 degrees should be 0. Cos of 180 should be negative 1. Cos of 270 should be 0. And cos of 360 should be 1. For tangent, we know that from your calculator, tangent of 90 degrees should be what we call undefined. Therefore, you have an asymptote here. We call this dotted line as the asymptote. So your graph will be dancing something like this. All right, will be dancing. So I don't know how to describe it. I always imagine this as a dancing graph. Right. So it goes to 0. All right, it's dancing like that. Okay, and if you extend this one, something like that. Right, it will never touch that asymptote. Okay. So you know that tangent of 90 should be 0, tangent of 360 should be 0, tangent of 0 should be 0, and tangent of 90 should be undefined. Alright, so let's look at these questions for the trigonometric ratio. Suppose we have this sine A and tangent B, which is given by this, and we know that A is an acute angle. Read the question carefully. And B is an obtuse angle. You can start sketching your acoustasy. Actually, you have to use acoustasy quite a lot for this type of questions. So A is an acute angle, meaning that it will be in the first quadrant. So this is your A. Because we are given with sine of A, which is actually 3 over 5. So sine is actually opposite over hypotenuse. So opposite of A is here, 3. And hypotenuse should be 5. So by Pythagorean triple should be 4 here. And B is an obtuse angle. So if it is an obtuse angle, it should be here. And we know that B in this case only sine is positive. So of course our tangent is negative. Alright, so we are given with tangent of B. So we know that TOA, opposite of adjacent. Opposite of B is 12. And adjacent of B should be 5. TOA. and should be 13 here by Pythagorean triple. What about the negative one? The negative just indicates which quadrant it belongs to. So now we have this one. We want to find sine of a plus b. So we have to use the, what do we call? The trigonometric identity. All right, so sine of a plus b should be given by sine a cos b plus with cos a sine b. All right, so we should find the sine of a. So look at this a. So of course everything is positive there, so you don't worry about the symbol for the positive or negative. So sine of a is actually given by 3 over 5. You multiply with cos of b. In this case, cos of b is here, so cos adjacent over hypotenuse, so 5 over 13. So 5 over 13. But on this quadrant, only sign is positive. In this case, cos is actually negative. Therefore, we have a negative there. Plus with, all right, cos of a. Right, cos of a, of course, a is, everything is positive. So, adjacent over hypotenuse. So, 4 over 5. And then you multiply with sine of b. In this case, sine of b is so, okay, so opposite over hypotenuse. So 12 over 13. Is it positive? Yes, because in this quadrant, sine is positive. Alright, so you can actually calculate this by using your calculator. Alright, I'm not going to proceed with the calculation, so you calculate what value is it. Alright, for the second one, alright, so you have tangent of a plus with cosec of b. So I need to use the, what do we call, trigonometric identity to simplify this one. So you know that cosec of b is actually 1 over s here, so 1 over sine of b. So tangent of a, in this case, a is always positive, so tangent should be positive. So tangent is given by TOA, opposite over adjacent, so 3 over 4. You plus with, alright, 1 over sine of b. Look at b. B sine is positive, so sine so opposite over hypotenuse, so 12 over 13. All right, so you can actually simplify this one, 3 over 4 plus 13 over 12. So try to simplify this one using a calculator to get the answer. Is it easy, right? All right, let's go to the next one. Second example, suppose we have tangent of a, which is given by this negative 3 over 4. Tangent of b, which is given by this 12 over 5, where a is an obtuse angle. So we know that when a is an obtuse angle, should be on this side. Okay, a is an obtuse angle, therefore our tangent a s t c. So only s is positive here, so of course tangent is negative, so TOA, alright, so we know that this is TOA opposite, which is 3 over adjacent 4, hypotenuse should be 5. And tangent of b, and b is an acute angle, so of course b should be here. Alright, so b should be here. And it is given by tangent of b, so TOA opposite, which is 12, adjacent should be 5, of course the hypotenuse should be 13. Right, so you are done with this one. This is your first step, right? Without using calculators, find the sine of a minus cotangent square of b. So this is actually, all right, let me just write this. Sine of a minus cotangent square of b should be given by sine of a minus cotangent is actually 1 over tangent b squared. So, all right, so another important thing that you have to know, if you have, like, for example, sine square of a, so this is actually equal to sine of a, you square it. So it then goes to this one. If you have, like, for example, cotangent square of a, so this one is actually 1 over tangent square of a. So you can actually put this in a bracket like this. All right. Now, you can actually try to find this one. Right, so sine of a, look at your a, sine is positive, so sine, so, all right, let me just write, so, TOA, it will be used quite a lot here. So, sine is this one, so opposite of a is 3 over 5, so 3 over 5. Is it positive or negative? Yes, it's positive because sign is positive on this side. Minus tangent of b. So b is on this side. So tangent of b squared. So meaning to say that you have 12 over 5 as given by the question. So squared. And you try to simplify this one. Alright, so you get 3 over 5 minus, I guess, 25 over 144. Alright, so you try to find the value. Okay. Now, you have this cos A plus B, so you have to use the trigonometric identities to solve this one. So you have to use cos A, cos B, because it is plus there, it will be minus sine A, sine B. Alright, now let's express it with cos A. So cos A, alright, so cos A, of course, only sign is positive here, so cos it should be negative. So cos is actually adjacent over hypotenuse. So adjacent is this one over hypotenuse. So 4 over 5, but it is negative because only sign is positive on this side. And cos B should be adjacent over hypotenuse, so 5 over 13. But why is it positive? Because all is positive here, means that sine, cos and tangent is positive on the first quadrant. We minus sine of A, sine of B, right? Sine of A should be positive, right? So opposite over hypotenuse. So you get 3 over 5 multiplied with sine of B, opposite over hypotenuse, so 12 over 13. Right, I hope you can simplify this one and you get the final answer. Right, so as simple as that. And let's look at the last example I'm going to show today. Right, suppose you have this one. Right, so you have sine of A is given by this and cos of B is given by this, where A and B lie in the same quadrant. So be careful with this one. This statement is very important. All right, so let's just draw this statement, the quadrant. So you write acoustasy here. All right, so we know that when sign is actually positive like this, so it should be either this way or this way, but A and B should be in the same quadrant. All right, so we know that A can be either here or here, but B, or about B? B is negative. Can it be here, B? No, because everything is positive here. So this quadrant is not. Therefore, A and B is in the second quadrant. So you have, suppose you have A, sine of A, which is, all right, so let me just write socha and towa. All right, so opposite, which is 12 over 13. So 5, it should be here. And for the second one, for B, because they lie in the same quadrant, therefore it's better for you to draw this on another quadrant, another diagram of the quadrant. So we know that B, all right, so I'll just write acoustasy here because B is negative. So 3 over 5. So you assume B is here, and cos of B, adjacent over hypotenuse, so it should be 4 over here. All right. So, but what about the negative? Just negative, it just states that B is in this second quadrant. So you should start with finding second of 2A. Second of 2A is actually given by 1 over, right? Second is actually 1 over cos of 2A. And by the trigonometric identity, so you can use either 3, right? So you have 3 formula for the cos of 2A. So suppose I want to use 2 cos squared of A minus 1. Means that I have to find 2 multiplied with cos of A squared minus 1. In this case, I need to find the cos of A. Look at your A is here. Is it positive? For cos, it should be negative because only sine is positive from this side. Therefore, I will have 2 multiplied with cos of A, adjacent over hypotenuse. 5 over 13, but it should be negative. Why? Because it is actually on the second quadrant. Only sine is positive, therefore cos should be negative. You should square it according to this formula. And then you minus 1, and then you can finding this using your calculator. It's easy, right? And the last one, you will have the formula for the tangent of A plus B should be given by tangent of A plus tangent of B over 1 minus tangent of A, tangent of B. All right. Your tangent of A, both A and B, tangent should be negative because only sine is positive on this quadrant. So tangent is actually opposite over adjacent. So opposite over adjacent, 12 over 5. So 12 over 5 should be negative. You plus with tangent of B. Tangent of B is actually TOA, opposite over adjacent. So it should be negative 4 over 3. Why is it negative? Because it is on the second quadrant. Only sign is positive, therefore tangent should be negative. So you divide with 1 minus that one, negative 12 over 5. Minus 4 over 3. Pressing your calculator, you'll get your final answer. So this is how your question for the trigonometric ratios looks like. So try to practice more questions. I wish you good luck on solving these type of questions.